If we look at everything around us, we see rules and patterns. Much of what we see was created by us. Language and numerals and computer binary code. We invent systems for these things that make sense to us. We learn this from nature. Atoms, DNA, the solar system. We are surrounded by mysterious rules that need to be uncovered. This is what scientists do. The fields of science, technology, engineering, and mathematics, abbreviated to the term STEM, represent both the force that drives humanity to innovation and progress and, more practically, is a rapidly increasing job market. However, in the US we have more STEM-related jobs than people to do them. It will get worse in the future as children seem to be losing their proficiency and interest in science. Of course, this doesn't have to be the case. According to the Department of Education, children enter school with positive attitude towards science. They start losing their interest around the 3rd grade, and this decline continues until the 8th grade. By the time they reach high school, most children have already established either a positive or a negative attitude towards science, and will not easily change their position. So we have to start young, grab their attention at an early age in a way that will be hard to forget. That brings us back to rules, and the core principles of the scientific method. I want to introduce a game to young children that they can play in a group. It's a challenging game, and one that will give each of the players a chance for being in the spotlight, an option I'm sure will appeal to them, and solve a mystery. After they play and enjoy the game comes the educational part. In this part, the kids will see how the process they were using in their game is used for scientific research. With the memory of their recent success in the game, this experience is bound to leave a positive impression in their mind, hopefully helping them remember some of the very basic concepts we need for proper science reasoning. The game is called Eleusis, or New Eleusis to be exact. It was invented in 1956 by Robert Abbott and perfected over the years with the help of many educators and scientists. Martin Gardner helped to publicize it when he wrote about it in his Scientific American column. In his article, he introduced it as a game of inductive reasoning. Inductive reasoning is a formal way of saying observing specific cases to reach a general conclusion. Here is an example. In the 17th century, Galileo Galilei was attending a religious service when he noticed the motion of the chandelier. It seemed to go back and forth at a steady pace. This curious observation led him to test pendulums. What will affect the time it takes the pendulum to make a single trip? The mass, the length of wire, the point where the pendulum is released. Surprisingly, only the length of the pendulum, and the gravity which causes the movement to begin with, can affect the time it takes for a single pendulum swing. The exact equation was discovered later, but this knowledge was enough to develop a new invention, a mechanical clock. The scientific method in action is not always a simple thing, but we can roughly divide the processes used to two: deductive reasoning and inductive reasoning. We can also call them the top-down and the bottom-up approaches. In deductive reasoning, we start with something general, a theory. We use it to form a hypothesis about the problem we want to solve. We create tests that will check our hypothesis and observe the results. Then, based on the results, we either confirmed our hypothesis to be true or false. In inductive reasoning, we start from the specifics. In this case, with observations of the situation we are studying. We observe until we detect emerging patterns, and from those we formulate a tentative hypothesis. When we are sufficiently happy with the test results of our tentative hypothesis, we conclude a general theory. Adapted to a game of cards, we start with one player who is nature, that makes up a rule. For example, a number between ace and 7 must be followed with a number between 8 and king, and vice versa. The other players don't know this rule. They are the scientists. They each get 14 cards that they want to get rid of, and they choose one in every round. Nature declares the card to be correct or incorrect. If the card is correct, it goes on the main line, and its player has one card less. If it was incorrect, it goes on the sidelines, still valuable to understanding the rule, and its player must take a new card. After several rounds, one of the scientists may declare he has a hypothesis. To test it, he replaces nature in the role of calling cards correct or incorrect. If he calls correctly for the next rounds, he wins the game, but with one false call he is overthrown with a 5-card penalty, and nature resumes control of the game. It's an engaging game, but sadly I've only mentioned some of the game instructions. The complete set of instructions is more complex, and the rules that nature can devise can be of a nature more intuitive to some people than others, like alternating cards that have prime numbers with cards that don't might appeal to mathematicians more. The game as it is now is more appropriate for grown-ups. For this reason I suggest to research a way to keep the game's essence, but use simple game pieces and allow a restricted set of rules. The new game developed in this research will be eventually turned to an application and allow the computer check the game is going on correctly. A child player can still have the option to declare correct or incorrect, but the program will validate that he is doing it in accordance with a predetermined rule. This will help the players avoid simple mistakes that might make the game confusing and therefore not fun, the worst possible destiny for a game. There are many game elements that should be considered during the research period. The desired ages are between kindergarten and 6th grade, but it is very likely that different levels of difficulty will be needed. We must find the optimal number of players so the game will be interesting but won't drag for too long. Maybe there is a good way to incorporate a single-player mode. We will need the help of game developers, science educators, and scientists. We will come up with many options for game pieces, rules, levels of difficulty, and possibly a background story that will work with a science theme. The possible games will be tested using paper prototypes on children of primary school age and conducted in school environment. Options with good balance and playability will be refined and tested again. When the game mechanics are decided and a visual design created, it will be programmed to an application for a tablet that can be played by a group of children or a family. This game should be accessible, affordable, and should be promoted not just to teachers, but to parents as well, since in the early years of education they still have a big influence on their child. Not so much in their child's teen, but at that point I hope the kids will have plenty of high school STEM programs that they will want to attend.